Hello and welcome to the first episode of the 12 Cylon Challenge, in which I attempt to build one robot per month for the rest of 2016. This video, being an introductory one, is mainly going to be setting the tone and talking about what you can expect from the challenge, but at the end, if you are looking for some technical stuff, I'll start talking about my first robot and kind of my plans for it and what I'm planning on doing with it, and I'll go through some of the components that I've bought. So the story goes that I was browsing through Facebook when I find this post by Mark Zuckerberg, because of course everyone follows Mark Zuckerberg, and he was talking about his New Year's resolution, and his resolution is more of a challenge for the year of 2016 to build a piece of AI software that manages his house. So, looking at this, I'm just like, well, I was just gonna go work out more. Way to make me feel like a jerk, Mark. I'm gonna give myself a challenge too. And so for me, I study computer science, and I like robots, right? And I talk a lot about robots, and I post a lot about robots, and I'm bugging the hell out of all of my friends with robots, but I actually haven't built very many. And this feels like a big gap in my knowledge, so I decided, well, why not put my money where my mouth is and try and build some robots? Just as a disclaimer, I'm going to use the word robot a lot in this series of videos. I'll try and find synonyms, maybe droids, bots. We'll come up with something. So the original plan was that I was going to build just one. And then I thought, no, that's not enough. I'll build three. And then when I was thinking about building three, it's still very few. And the problem with building few is that you'll have so much time to do it that you'll come up with all of these features that you want to do. You're going to be like, oh, I have all this time. I'm gonna make it do voice recognition and image recognition. It'll talk to you and it'll fly and it'll have lasers. And you're not going to do any of that. You're not going to do any of those things. That's too much. So I decided, well, I'll make 12. It's a challenge, so it has to be big, it has to be ridiculous, because what's the point of a challenge if you don't stretch yourself? It has to be something that you might potentially not finish. That's the fun of it. So that's what I'm doing. And the idea is, if you build one a month, and given that I have other commitments to do, and this is only really going to be a hobby project, I have to move quick. I have to go fast, and I have to I'm going to have to keep them simple. And that forces me to focus on basic principles and to really immerse myself into the foundations of robotics, rather than look at all these lofty ideas and not make them at the end. I would rather make 12 robots than one and a half awesome ones. Really, if I could make one awesome one, that would be fantastic. But at this point, some of you are probably wondering why it's called the 12 Cylon Challenge, and that's a reference to Battlestar Galactica, which is my favorite show of all time. Cylons are a type of robot. The number 12 also has significance. I could explain that significance, but it's sort of spoiler territory, and I'm going to make you go watch the show. Or Google it. So what can you expect from this challenge? So for me, like I said, these robots are going to be really simple. But how simple are we talking? We're talking, to begin with, maybe obstacle avoidance, robots that follow lines, things along those sorts of lines. I'm starting with the puns early, aren't I? But just because the robots are simple doesn't mean they have to be boring. I mean, if we say that I'm spending 8 hours a week on this, right? And 4 weeks in a month, that's about approximately 30 hours. Might be more, might be less, but that's about the same as your average hackathon. And hackathons make some really cool stuff, yeah? So think, why can't I make something that's both simple and also cool? So I have a few gizmos at my disposal. I have a Kinect upstairs. Kinects have the ability to detect depth. They have the ability to monitor objects as they move. So what's to stop me from, say, making a robot that moves according to my gestures? It's very simple. All it would need is the Kinect connected up to a Raspberry Pi, connected up to an Arduino, which is connected to... Okay, so for some of you who aren't of a technical background, that might be tricky. But the long story short is it would just be a few simple connections and a little bit of software. Definitely something that you could do in the scope of a month. Very doable. So the robots are going to be simple, but that doesn't mean they're going to be boring. We'll try to make each one different. There'll be a little bit of a twist each month, but we'll see where we go, right? And I imagine that probably towards the end, my definition of what a robot is going to get looser and looser and looser. A robot is really something that responds autonomously to external stimuli. So when you think about it, isn't this really kind of a robot? By the way, my friend Matt has graciously offered to help me out with this project. He comes from a mechatronics background. He knows more about hardware and electronics and mechanics than I do, so he's going to be giving me tips. He's already started. But Matt doesn't want to appear in any videos, so for our purposes, he will be represented by this Ultron bobblehead. How you going? So now let's move to talking about the actual robots. Let's talk about the first one for this month. So this time, I was thinking about how do you start something like this? What's the first robot that you make? And I was thinking, well, my purpose is to ground myself in these ideas of robotics, to learn how to make them. So I thought, well, why not break free of kits? Because at the moment, my knowledge is largely software, and I'm dependent on kits. So I thought, well, why not build a very simple one, but using no kits? So this is something that I built before. This is the one robot that I made before. We'll get into what it does in another episode. But what this one did what this one can do is, you'll see that here, this is the microcontroller. This is an Arduino. It's basically the brain. These are like the eyes. They sense distance, and they detect obstacles. And obviously you have little motors here in the legs. So what this one could do potentially is, it would see an obstacle, and it would be moving. And then when it sees an obstacle, it stops. It turns around, and then it moves in a different direction until it finds another obstacle. And as you can tell right here, you'll see these little bits here. This was built with a kit. So why not make something like this, but without a kit? Yeah. So I came across this, I googled easy robots to make, or basic robot tutorial, or how to get started with robotics. And I found one. Now, if my video editing skills are good, then you will see it now. And I'll hopefully be able to get the audio to go over the picture. If not, then you just have to look at my face. I'm sorry. So what this website did is, it gave you instructions on how to make the robot, and it told you the parts you would need. And then as this tutorial became more popular, they started putting all those parts together in a package and allowing you to buy them all in one go, because it's designed for people who've never done anything with robots ever before. And so it's a good deal in that way. But for me, I thought, well, that sort of goes against the spirit of what I'm trying to do. I want to be able to make robots without a kit, even if it's an unofficial kit. So I thought, I'll get these components individually. The other thing is that the kit costs 130 Australian dollars, and I'm not going to pay for that at all. I'm not going to pay for that. So let's break down why it costs 100. Like, that doesn't even include shipping and handling. I want you to understand this. If I do that every month for the next 12 months, that's like $1,800. And that's not happening. That's not happening. So the first thing that I've done so far is I've gone out and I've bought all the components that I need to build my robot, and I have everything available for me. I'm ready to start. But let's talk about what those components are and why the kit was so expensive. So the first thing on the list was a microcontroller. The microcontroller is the brain of the robot. I showed that to you before. So I was looking that up, and that was, it was a microcontroller. It had a cable. It had a CD that explains how to use the microcontroller. It had various little components that go into it, and all of that together cost $50. No, that's kind of on the high side. Like, granted, it's an entire kit, but it's still on the high side. And the other thing is that if you look it up, it was only on one website. I only managed to find it on one site. It wasn't used anywhere else. And the reason for that is because it's just this weird controller, microcontroller, that I don't think anyone uses. So instead, I dug up this. This is an Arduino Uno. The Arduino is a type of microcontroller that is very popular with the hacker community. It's open source, I believe. It has lots of tutorials out there, and it costs $20. And I had it lying around from another project that I did before. So I decided to use this. And I have the cable and I have everything. So I'm using that. So there, that's $50 saved. Then there was another component called an IR sensor. The IR sensor is infrared. It's basically the eyes of the robot. And it senses, and that one was about $25, $30, something like that. Also no, I had this lying around. This is an ultrasonic sensor. It does the exact same thing, costs $3. It doesn't do the exact same thing. It does it differently. One of these sends a signal outwards, and that bounces off a wall and gets sensed by the other one, and that's how it measures distance. Really cool, really cheap. In fact, it's so cheap that when I first found out how cheap it was, I went and bought a bunch of them. A bunch. So that was the other thing we bought. So that's another about 30 bucks that we saved. So we've cut down about 80 so far. Then there was the servos. Turns out I had some lying around. So I'm sort of cheating with this because I'm making it out like I saved all this money. I'm so smart, blah, blah, blah. But I really just had all this stuff lying around because I spent money on it before. But that's kind of the spirit of robotics, sort of, is that you reuse the stuff that you have lying around from older projects. I don't have a problem with that, and that will save me money in the long run. And then there were other things that I didn't have, so there was the motor. There were all these. This is the one that maybe I wasn't too clever with it. We'll find out. The motor was, they had all these specifications, like they said, it needed to be a geared motor and needed to be blah, 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 blah. They just had this list of stuff. So I found this one for about $9 each. I got 2 of them. I think it'll work. We'll find out if I made a good purchase or not, depending on whether anything catches fire. So that about covers everything that we need to say for today. I could go into more details about the other components that I bought, but they're really just a couple of wires and resistors and things like that. The nitty and gritty of what you need to know for this robot so far is that it'll be these sensors giving input to this microcontroller, which will then give output to this motor, 2 of these motors. And that's effectively it. That about covers it for this video. I will get to work on the robot in the next couple of days, and then hopefully once I have some progress, I'll post another video letting you know of where I am, whether I've succeeded, whether I've failed, and our plans for the future. See you guys then. I forgot to mention, I'm also documenting this in a blog, so you'll find the link to that in the doobly-doo, but there will also be a link to the tutorial that I'm modifying to make this robot. That's all, for real this time. Until the next video.